Hello, I'm Reza Berkan, and today's topic is time, the devil of physics. What is time? What makes things change, move, or evolve? Is time some invisible hand, some mysterious pacemaker, or is it just a ticking machine we made it up? I call time the devil of physics because it's hidden in plain view, fooling even the most sophisticated scientists, and maybe the root of every roadblock we encountered in scientific thinking. To remind you of the fact that there has been no physics experiment where the time was measured directly. Scientifically speaking, time is a big unknown. So we ask, are time and clock two different things? This is the main investigation in this video series. We want to identify an unknown because we want to progress from we don't know what we don't know to we know what we don't know. This is not a philosophical word game. This is a true scientific statement. I will split the definition of time: physical time representing the physical reality and clock time representing mathematical reality. The difference between physical reality and mathematical reality is explained in a separate video coming up on this channel. Of course, we know the clock because we make the clock, but we don't know anything about physical time, if it exists. As the highest authority in this subject, let's look at Einstein's famous 1905 paper. Einstein says time is defined and measured by clocks. Einstein is very careful in his articulation of clock versus time. In a way, he acknowledges that time may be different than clock. And we will examine this later in this series, but now let's look at our regular clock for a moment and see how useful it is. We need a reference point to organize our lives to become productive. We build things, we cook meals, we travel distances, we celebrate birthdays, etc., etc., all using the good old clock. We don't care about the meaning of time beyond this practical outcome, right? Why do we care if time has a different meaning than what clock says? Well, there are two reasons we want to know time from the human perspective. The first one is curiosity. Clock is fine in our microscopic world, the world we live in, but we are naturally curious about the astronomical world. Does the clock work for this purpose? And we are curious about small things, the atomic world. Does clock work there? Our current science assumes they do. Clocks are applied to every domain, but is that assumption reasonable? The curiosity angle produces our God questions. Where did we come from? Where are we going? How does the universe work? Interestingly, all these questions are time related. But there's a second reason why we need to understand time: fear of death. How long are we going to live? What is after life? What was before life? Time really matters when we deal with life, living bodies, organisms, flowers, agriculture, etc. We don't care what happens to a clock, we care what happens to us. So the physical time, physical reality for us is biological reality, biological time. Therefore, I will modify this picture and include biological time to the comparison to clock time. I will symbolize it by the growth of a flower. That must be the most important, the highest priority investigation about time. Biology is well defined by carbon-based life. 99% of organic material is made up of these 6 elements. But the most striking aspect of biological time is that there are timers encoded in our DNA. One of them is called sirtuin-1, a gene that defines the pace of life. This is like a message from the Mother Nature about how to define time. It's a beautiful clue and a reference point if we can completely understand what it means, what is underlying mechanism. And we will talk about this later in the series. Going back to this chart, arguing whether clock can be applied to astronomical world or atomic world, the same clock is used for a galaxy and for an electron. Now I'm going to include biological world. So we have clock describing the world we live in, but in 3 other domains we don't know time and the physics behind it. So why am I drawing a picture like that? As if I'm assigning myself the most impossible task of classifying an unknown, and classifying an unknown like time in 3 different ways. I drew this picture for a good reason. You see all these theories using clock. They cover the atomic world, the astronomical world, but there is no unified explanation. Physics theories using the same clock are all conflicting. Alright, let's recap. All these scientists of the last century photographed during the famous Solvay conference. Those great minds who developed theories across the board, they all use the same clock concept everywhere, even Einstein. Well, how about the new generation of physicists? These are only YouTube celebrities, not to be compared to the previous picture. Let's look at one example and see what they say. General relativity theory by Einstein says that the clock in a higher orbit runs faster. Here is Professor Khalili explaining the theory.
I've got 2 identical clocks here. Now, because the clock lower down is closer to the center of the Earth, it feels ever so slightly a stronger gravitational pull than the clock higher up. Einstein's theory says that the lower clock will tick by at a slightly slower rate than the higher clock. Basically, gravity slows time down.
Did you catch it? He assumes time and clock are the same. Well, I'm not going to show you all the others, but I watched them all, and all the physicists make very similar assumptions. When they talk, they interchangeably use clock and time. Almost they are equal, they mean the same thing. So we really haven't progressed an inch from where we stood 200 years ago. No imagination whatsoever. That may explain why we are stuck between conflicting theories. In the next videos, I will examine time from this perspective. Remember this picture, we will examine all the question marks there. Maybe we will inspire some scientists to come up with new ideas. Who knows? Thanks for watching. Until next time.